Hi everyone, welcome back to my channel. My name is Jaison Mathew. In this video, I'm going to talk about local web authentication on Cisco Wireless. In this video, I'm going to cover four scenarios. One, local web authentication with local users, and local web authentication with external user credentials using a AAA server or a Radius server, LDAP, that kind of external servers. Third one will be with Anchor, the same combination with Anchor local users, with Anchor external users. But when I say external users, only the user credentials will be outside the WLC. I'm not referring to the external web authentication. That will be covered in a different video. Let's get into the local web authentication with the first scenario. The first scenario is you have a WLC and your guest user credentials are actually stored on your WLC itself, and how that is going to behave in your network, and what are the things you have to take care when you do this deployment model, right? Let's see how the guest access works on Cisco Wireless with this combination WLC and local user database, and what are the flows that happens in between client, AP, WLC, and DNS servers like that. So to begin with, the first one will be the association request, and the association request will be sent by the guest client to the WLC through the AP, definitely, and WLC will be responding back with the association response. Once the association response is reached to the client will be trying to get an IP from the DHCP server, and it will be sending a DHCP handshake to the server. And you have to go through the WLC, so client will be sending it to the WLC, and WLC will be forwarding that to the DNS DHCP servers, right? And DHCP will be provided, the IP will be given to the client. But before this, I'm not calling it out the pre-auth ACL specifically here because it's not mandatory on this model. If you want to add extra security, then definitely you have to have a pre-auth ACL allowed on your network, and that will be used for multiple reasons. One, to control the traffic, to give the restricted access to your guest client. And if you have a pre-auth ACL, then the pre-auth ACL should be allowing your DHCP and DNS traffic communication between client and the server. So this DHCP server or DNS server, it can be like local to the network, it can be external to the network. So either way, you have to make sure this client IP pool, the guest client IP pool, is having a reachability to DHCP server. And your pre-auth ACL should not block DHCP or DNS. It's both are applicable here. So if you have pre-auth ACL blocking your DNS server, then ultimately this flow will not work, because you need to resolve that DNS name or the FQDN name for any kind of captive portal. So when we say captive portal, once you get the IP address, the first thing the client will be trying to do is to find a captive portal is available or not. So each operating system have its own ways of finding it. Android will have its own way to find it. Apple iPhones will have its own way to find it. Then your Windows will have its own way, and iOS, MacBooks will have its own way. Linux will have its own portal detection methods. So either way, it's a URL, and it will be a URL, and you can get that URL list by googling it. But what I want to stress here is that URL will be something that it's going to try to resolve. So this resolution, the FQDN resolution of that portal, should be successfully completed. So in case of ICE and CWA, it's a different flow. I don't want to confuse anything with that because there is a slight difference on that. But right now, you have to make sure your pre-auth ACL is not blocking any of the DHCP traffic or DNS resolution, because this is the key. You need to have the DNS resolution successfully completed so that you will get an IP address and client can establish a connection to that client, that particular server IP. If you are putting a pre-auth ACL, then you have to make sure uh, the communication is allowed on the pre-auth ACL. Even if you are not putting the pre-auth ACL, you have to make sure this communication is possible to establish in your network. So you have to have that routing and everything taken care, and no one is going to block this communication between the guest IP pool and this DSCP or DNS server. When we talk about captive portal detection mechanism, basically there is an automatic way of detecting it. That's the one I was referring last time. And there is another way that you will wait for client to generate some web traffic, and that will get into the redirection, right? So as I mentioned before, it can be something like captive.apple.com or something like that. Or if the automatic detection is not working, you can go to your browser, or any web traffic that is getting generated from the glass client will trigger this. So you have two triggering mechanism. One is automatic one that will be based on your operating system. The second one will be coming from your manual intervention, something like you are going in and typing google.com. So when you say google.com, the above step that I mentioned, DNS resolution, will be going to google.com, and it will be intercepted by the WLC, and that WLC is going to give its own login page. Instead of google.com homepage, you will be getting a login page from that, and it will be coming through your virtual IP. So you will be able to see that your virtual IP is getting utilized at the backend some for most of the time, and you will be able to see that login page coming from WLC. So once you get the login page, now you have to do the authentication, right? So when you say authentication, L3 authentication have multiple options. So in case of Cisco Wireless, we have authentication, that is user credentials authentication. Then you can have a pass-through. Then you can have a conditional web redirect. Then you can even have splash page. Uh, that is something like you will just show a splash page and just click on OK, then you are good. So, you will have that user acceptance kind of agreement kind of policy that will be shown in your screen. So, in any case, the login page can be anything from WLC, but in this one line, I'm just saying this is the page that guest is going to get it in his own laptop or desktop or your mobile or tab or anything. And you have to take the action based on that page. So it can be anything. I'm just using one liner here, but this can be anything. And once you get the username and password, so in this particular slide, I'm actually talking about a user credentials login. So in that case, so you'll be getting a login page, and in that login page, you have to enter your username and password. So when you enter this username and password, this will be going to get cross-checked on internal database for the WLC. So when we say internal database, it can be local users or local net users on the WLC itself, and that will be the username and password for the guest. So this is something like an overhead for operations team, and that's the main reason no one really uses this feature. But this is the WLC capability, and WLC will be hosting the login page. WLC will be having all the user credentials, and lobby admin can be used at the backend, and you can keep adding the users into the list system. And these kind of things, these days, a lot of people are not using it, but there are some small deployments that uses this one. So you have limited resources available for Radius or any other kind of authentication mechanism, then the entire thing will be handled by the WLC. That's where this one comes into picture. Very small deployments always can have this kind of model used at the backend. Then the request, the login page request, the user credentials will be entered by the user, and it will be hitting on your WLC, and WLC will be checking that policies based on the web authentication. It can be user policies, user credentials, it can be pass through, as I mentioned, conditional redirect or splash page or anything like that. And based on that, it will be taking care of that activity. WLC will be responsible for this action. Once this action is completed, then it's a successful authentication. Then, so user credentials are passed or web pass through. You gone through the policies and you accepted it. Then pass through, you just gone through it. You accepted that splash page. So any condition, the WLC has to take an action, right? So till the time you successfully authenticate, you will be in a client state called web auth required state. So this is the state of the client till the time you are uh, you are uh, you are into that authentication process. So once the authentication process is completed, then you have to move, the WLC has to move this particular client into a run state. So that's where this web auth required state will change to run state, and it will be allowing the client to pass the traffic to the internet or the network. When I say network or internet, with guest or without guest, you can use the same model. If you are using guest and if you are giving only the internet, you can give that. But sometimes you will not give the internet, but you will give some other network access that will allow the user to access the internal resources or something like that. That's why I just mentioned internet or the network here. When this client gets moved from WebAuth required to run state, that's a time, if you have a pre-auth ACL, that pre-auth ACL will also be get removed, because pre-auth ACL is applicable during the WebAuth required states. Even if you have it or if you don't have it, this is the time client will be able to access the internet in a normal way. This is the entire flow in local web authentication with local user database on the WLC. As I mentioned in the beginning, we have three more scenarios. It's more like similar, but there are some slight differences. We'll get into that. So here I'm talking about a external Radius server. So it can be Radius server, it can be LDAP, it can be any kind of Radius servers. Anything capable of doing Radius authentication can be applied here. Till the authentication guest login page, everything is same. So no difference on this model. But when we talk about the user credentials, the difference will be your WLC will be hosting the page, but when you are giving the username and user credentials into that page, WLC will take that information and it will pass this information to your Radius server, and it will authenticate against the Radius server database. So it's not a local database anymore. The user credentials are not stored on your WLC. It will be stored on a centralized Radius server, and that Radius server will be responsible for any authentication. And as you can see here, the WLC will be sending a access request to the Radius server, and Radius server will respond back. It can be access accept or the reject. Then once the authentication is successful, the Radius accounting messages will be passed between these. I just added that. It's not mandatory. Accounting feature is not a mandatory thing in AAA scenario. So when you say AAA, the authentication, authorization, and accounting, right? So in that scenario, accounting is not mandatory, but if you have accounting enabled, then this is the place you are going to do that. I'm just saying there will be a communication between WLC and Radius for accounting information to be passed. If you have a Radius server, yeah, this is where you are going to pass the accounting information. Then the client will be allowed to pass the traffic. Basically, the web auth required state will change to run state. And if the authentication is failed, then it will be the status will be like deleting the client. So you will be out of the network. You will be kicked out of the network if your authentication is not passed. Successful authentication is completed, then the client will be able to pass the traffic. So this is the scenario with an external Radius server coming into picture. Means the user credentials or the user database is not situated on the WLC. This scenario, local web authentication only, but with the Anchor controller. So this is most of the time, this is the deployment model that happens if you need a requirement of or compliance requirement of isolation of guest traffic, because guest traffic is not a trusted traffic in your environment, in any network environment, right? So guest access is not a trusted traffic. So in that scenario, you have to have some kind of control on your network and the traffic flow between the guest client and the internet. So if that's the case, the available solution from Cisco is an Anchor WLC. So Anchor WLC is nothing but a WLC sitting inside your DMC zone. So what will happen here is whatever communication comes from the guest client, it will be coming to your foreign WLC. So in this scenario, the local WLC will be called as foreign WLC, and the one sitting inside DMC zone will be called as Anchor WLC. So whatever comes from the guest client, it will hit on the foreign WLC, and it will create a mobility tunnel between foreign WLC to Anchor WLC. So I mentioned EUIP and CAPAB. EUIP is the legacy one, that nothing but the old one used by the iOS devices. Going forward, you will not be seeing that that much, because all the iOS is getting into uh, the uh, the iOS XE model, right? The 9800s. So once you completely move into that, then you will be seeing only the CAPAP. So just mention both the combinations here. If it's not applicable, you can take out that EUIP. This is the protocol used by WLCs to communicate for that mobility ones. And when we talk about mobility, there are a lot of communication, management, and control traffics happen between these two WLCs. And there are some requirements on the mobility building, how you have to create the WLAN, and now what are the things you have to take care of this, the configuration point of view. So I'm not getting into all those things. I'm purely concentrating on the traffic flow here. But as you can see here, the key point you have to keep it in mind is foreign WLC is responsible for L2 authentication. So any L2 authentication in foreign anchor scenario will be handled by the foreign WLC. As you can see here, this foreign WLC is responsible for L2 authentication. So when I say L2 authentication, this is nothing but MAC filtering. Again, MAC filtering is not mandatory. If you have a MAC filtering, and if it's enabled, then foreign WLC will be responsible here on this particular point of time. And after that, everything is kind of a data plane, and everything will be handled by the Anchor WLC. So the DSCP handshake, again, everything is tunneled to Anchor WLC, and exit point will be on Anchor WLC. So you have to make sure it's reaching to the Anchor WLC, and Anchor WLC is having access to DSCP DNS servers at the backend. And if you have a pre-auth ACL, you have to take care of that. Pre-auth ACL also have this kind of allowed traffic on your network. Now the flows are same. Only difference is you are going to have L2 authentication handled by foreign controller, and data plane will be completely handled by the Anchor WLC. In this flow, you have to understand the differences that happens with the local web authentication if you have only one WLC, and what will change on second WLC come to picture as Anchor WLC, right? So the first one is layer 2 authentication. Second one is how the user credentials are going to be used, and it will be on Anchor WLC, and Anchor WLC will be doing that authentication part. Then Anchor WLC and foreign both will be involved when you are moving the client into run state. As we mentioned before, client will be in web auth required state, and it will be moving into run state, but the state change will happen from both the sides, like foreign WLC and the Anchor WLC. Then once this is done, your client will be allowed to communicate. Now, in the same scenario, we are adding a Radius server. The only difference between previous one and this one is the Anchor WLC will be contacting your Radius or the LDAP server to have that user credentials login, right? And if you have accounting enabled, then accounting messages will be passed between them. And after that, again, same procedure, web auth required state client will be changed to run state, and foreign anchor controller will be involved in that process, and client will be able to communicate the traffic, communicate with the internet or the network. So these are the four combination I want to cover in this video. Once I'm done with this series, I'll be uploading these slides into LinkedIn profile, and you can get that PDF format file from LinkedIn. And so when I say this series, I'm talking about local web authentication, then external web authentication, then centralized web authentication, along with centralized web authentication with SDA Fabric. So those are the four areas I'm going to cover in this series, and this is the first one, that will be local web authentication. And you can follow my LinkedIn for getting these slides PDF format. This video will help you to understand what is LWA so that you can differentiate with EWA, the external web authentication or centralized web authentication later, right? So that's the only idea to post this video. Hope this will help you on your learning journey. Thank you for watching.